All right, so implicit differentiation. So this I just copied straight from the book. It says the functions we have worked with so far have all been given by equations of the form y is equal to f of x. A function of this form is an explicit function. For example, y is equal to 4x squared plus 3x minus 2, y is equal to the square root of 2x plus 3 over x plus 4, y is equal to e to the x plus 2 are all explicit functions. There are functions in which y cannot be written explicitly in terms of x. In these functions, y is said to be in implicit form. For example, in equations such as x squared plus 3xy minus 4y cubed is equal to 4x, and x to the fourth plus e to the x plus y plus minus x squared y is equal to 6y. Y is defined implicitly as a function of x. The technique for finding dy by dx for implicit functions is called implicit differentiation. All right, there's nothing special about it really. Let's get into it. As usual, I will do the first one, then you do the second. Everyone should remember that when you differentiate y, you're going to get dy by dx. So let's have a look at example 30. Example 30 is asking us to differentiate y squared with respect to x. So we're asked to differentiate. So let us just say, all right, we're asked to differentiate y squared with respect to x. Now, when you differentiate y squared with respect to x, this is a power differentiation. So, and it's a power differentiation and chain rule all in one. So for power differentiation, the power goes to the front. So we have 2y, the power decreases by 1. Then we have to multiply by the differential of the inside function. The inside function is y. When you differentiate y with respect to x, you're going to get dy by dx. So your answer is, when you differentiate y squared with respect to x, the answer is going to be 2y dy by dx. Any questions, any comments? So it's a power differentiation. The 2 comes to the front. The power decreases by 1. Then you multiply by the differential of the inside function. The inside function is y. When you differentiate y with respect to x, you get dy by dx. So when you differentiate y squared with respect to x, your answer is 2y dy by dx.
Sir,
Yes.
so I'm not, how comes we have 2y dx and not just 2y?
Because when you differentiate the inside function, which is y, please remember, you're not differentiating y with respect to y. You're differentiating y with respect to x. Now, if I differentiate 2x, sorry, x squared, if I differentiate x squared with respect to x, I'm going to get 2x because I'm differentiating x squared with respect to x. But if I differentiate y squared with respect to x, not with respect to y, no, with respect to x, I'm going to get what? 2y. Then I have to multiply by the differential of y, which is dy by dx. This is just the way it is. So embrace it.
Okay, sir.
Come on,
I guess it's
embrace it.
because we have never done y.
You have actually differentiated y now. It's whenever you have like y is equal to, let's just say x squared. What you're actually doing is differentiating both sides. When I differentiate y, I'm going to differentiate both sides with respect to x. When I differentiate y with respect to x, I get dy by dx. When I differentiate x squared with respect to x, I get 2x. When you're differentiating, what you're actually doing is you're differentiating both sides. So you have differentiated y before.
Okay, sir. Thank you.
All right, guys, please try example 31. The only clue I would let you know is that when you differentiate, this is a this is a product. So you have got to use product rule. So you are differentiating x squared, y squared. You're differentiating this with respect to x. All right, let me see what you can do. All right, so if you're asked to differentiate x squared, y squared, that is a product differentiation. So it's a product differentiation, so I need to apply product rule. And when you apply product rule, what you do is that you leave the first, which is x squared, differentiate the second, which is 2y dy by dx, plus differentiate the first, 2x, leave the second, y squared. So our final answer would be 2x squared y dy by dx plus 2x y squared. All right, so let me look at example 32, then I'll ask you to look at example 33. Example 32 says, find dy by dx in terms of x and y for x squared plus 3y plus 2xy squared is equal to 4. So we have x squared plus 3y plus 2x y squared is equal to 4. And we're asked to find dy by dx in terms of x and y. Let's differentiate implicitly. So we differentiate 2x with respect to x. I'm differentiating the entire equation with respect to x. If I differentiate 2x with respect to x, I'm going to get 2x. If I differentiate 3y with respect to x, I'm going to get 3 dy by dx. Now, 2x y squared is a product differentiation. So I'm going to leave the first, 2x, differentiate the second. So that would be multiplied by 2 dy by dx. So that's leave the first, differentiate the second, plus differentiate the first. The first part is 2x. When you differentiate 2x, you're going to get just 2. Leave the second, y squared. And this is equal to, when you differentiate 4 over the right-hand side, you're going to get 0. All right, so let's get my dy by dx's together. I have 3. Let's put 3 plus 4x dy by dx. Tell me if you're okay with that. What I did, I put the dy by dx's together and I simply factor out the dy by dx. Are you all seeing it? You should be seeing it.
Yes, sir.
And this would be equal to minus 2x minus 2y squared. So positive 2x on the left goes over to the right and become negative. Positive 2y squared on the left goes over to the right and become negative. Then I'm going to divide both sides by 3 plus 2x plus 4x, sorry. 3 plus 4x. And so I'm going to get, this cancels that, dy by dx is equal to minus 2x minus 2y squared all over 3 plus 4x. So we were asked to find dy by dx in terms of x and y, and that is exactly what we did. All right, so yes, Jamila, you're correct. There is an error here. When you differentiate 2xy squared, you leave the first, so the first 2x is u, and y squared is v. You leave the first, differentiate the second. When you differentiate y squared, you're supposed to get 2y, so there should be a y there. You're 100% correct. And if we go straight through with that correction, we're supposed to have, this supposed to be 4xy, so there should be a y here, a y here, and a y here, and a y here. All right, and that should be the sum total of the correction. All right, so yes, I did make a mistake, and teachers will do that from time to time. All right, which is why you need good students to pick it up, so that we don't have a situation where people leave with the wrong idea or the wrong concept. All right, I need for you guys to look at example 33. Attention. All right, so we're starting out with 3xy plus 4x squared y cubed, and this is equal to 5x. And we're being asked to find dy by dx at the point where x is a half and y is 1. So let's differentiate. 3xy is product. So I'm going to leave the first, differentiate the second, dy by dx, plus differentiate the first, 3, leave the second, y. Now, to the right now, I have 4x squared y cubed, which is also product. So I'm going to apply product rule, which is leave the first, which is 4x squared. I'm going to leave that. Differentiate the second, which is 3y squared dy by dx, plus leave the first, differentiate the first, which is 8x, leave the second, which is y cubed, and this is equal to, differentiate the right-hand side. When you differentiate 5x, you get 5. Now, then I'm going to go straight and say at a half, 1. So wherever I see x, I'm going to put a half. Wherever I see y, I'm going to put 1. So this is 3 times a half, not 3.5. I need to be careful, not. So it's 3 times a half dy by dx, plus 3 times y, which is 1, plus 4 times a half square, multiplied by 3 times 1 square, dy by dx, plus 8 times a half times y, which is 1 cube, is equal to 5.
Say I have an answer.
Sorry?
Say I was saying I got an answer.
All right, fine. Let me finish. Then we can compare answers. So this is 3 over 2 dy by dx. This is plus 3 plus 4 times a quarter times 3 dy by dx, plus 4 times 1 is equal to 5. So now I have 3 over 2 dy by dx. This is 3 plus 1, which is 4, 4 times 3, sorry. No, my mistake. Fix that. So this is plus 3 plus this is 3 dy by dx plus 4 is equal to 5. 3 plus 4 is 7. Positive 7 goes over and become negative. So now I have 3 over 2 dy by dx plus 3 dy by dx is equal to 5 minus 7. 3 over 2 is 1.5. 1.5 plus 3 is 4.5. So 4.5 is 9 over 2. So this is 9 over 2 dy by dx is equal to minus 2. Then I'm going to multiply both sides by 2 over 9. I'm going to multiply both sides by 2 over 9. So therefore, I'm going to get 9 over 2 times 2 over 9 dy by dx is equal to minus 2 times 2 over 9. dy by dx would be equal to minus 4 over 9. All right, is that the answer you got? Jamila?
Sir, I did something wrong because I was like, oh, man, sir, have gone a different way. But I I had differentiated 3xy together, which is totally wrong. So that threw off my whole question.
All right.
I do understand. I'm going to do it over.